My name is Lucas, and I'm presenting a smart cane project. So basically, at this point, at this stage in the project, the smart cane is detecting an obstacle in front of the user. So the basic idea is that the three ultrasonic sensors are picking up the information about the environment. The microcontroller is processing that information. It gives the feedback. This is the vibration to the user. So that's pretty much it. If someone was to guess it.
Sure, why not? So what am I supposed to do?
So the way you hold it is, you put your thumb over here.
Okay.
So this one vibrates, it's still right there.
Okay.
This one vibrates, it's not it. This not it.
Okay. So all you have to do is
but it works for you?
Trying to move towards the big piece.
definitely telling me to turn right now. Nothing right yet, nothing right yet. I'm told to kind of turn left a little bit. Oh, turn right a little bit.
Sorry.
An autonomous flying robot that acts as like a personal cameraman. We designed it with the AeroQuad 32 Balun board for the flight control board, and we connect to it through Wi-Fi using a Wi-Fi unit, and we wrote our own iPhone app that can enable and disable motors, enable altitude hold, disable altitude hold, do auto lift off, auto land. You can also write different other commands just using a little keypad, a right command button. It also allows you to efficiently set PID values for tuning the quadcopter. The camera streams to a small little, it's an analog camera, so it streams to the receiver there. You can see it on the little TV.
Have you started it with the camera?
Yeah. Yeah, it's acting up. Power it off. Yeah.
You're not going to fly it in here?
We don't want dead people.
Hello, good evening. My name is Nigel. This is my project here. We are ARC Solutions, otherwise known as the guys who participate in the Freescale Cup. The whole idea behind my project is to understand the term autonomous and what it exactly means. What we have here is a Freescale card. Built off a quick stick microcontroller here. The whole idea behind it is that it's going to go ahead and take this camera that reads line by line of information and tries to differentiate where the white portions are versus the black line. By doing so, the car will be able to follow this line all the way around a track. It slows down the motors and actually turns the steering such that the car can always be in the right direction. Once the car is straight, the motors go to maximum. So that's our project.
How do you want to go?
Well, I guess she's talking about your thing.
Hello, our senior project for Team Mantra was to create a distributed.
Hello,
Hello, for our Team Mantra we designed a for our senior project, we designed a distributed power monitoring system. So what we did was we took a lot of the competitors' devices of monitoring power, like the kilowatt, which were more expensive and used were like not easy to use for monitoring power, and we designed it and designed our own system so that it would be very inexpensive to use and also very easy. We did that by two parts. We created an integrated power supply in our actual device to power our own circuitry, and then we added a wireless and RF modules into each of our probe nodes, and those nodes communicate with the control board. So it provides an instantaneous feed of what and how much power is being used by each probe into the control board, and then that displays graphically how you're using the power. And the team that actually did the graphical usage
Is Kuyashi, which is the software side of this. What that does is take the data wirelessly from launcher, displays it on a nice little table here. Play by time, device and power wattage of each device. After it takes that data, it transforms into a graphical analysis. And basically this graph will show. It'll allow you to choose a specific time of the day where you want to see which device is the most power. This will give knowledge to the consumer and to the user with the software which device is the most power at which specific time of the day. That way it'll keep you kind of conscious of what is using the most power. Our future form or our future features of this design is to actually give the user control to turn off those devices once it reaches a certain power threshold. That's it.
Thank you. Our system is the Anora home automation system, and we designed something that, there are home automation systems already in existence. However, usually the large majority of the time they are very focused on what you can do with them, and they are very expensive. So what we set out to do was pull off a home automation system with very inexpensive endpoint devices, which are output actuators or input sensors. They compile that information, ship it off to a coordinator, and then ship that information off to a server on the cloud. So all of your actual raw processing power is done off campus, so you can have that same complexity of a much more complicated device without needing all of the overhead and expense of those same nodes. So
yeah, basically it's like you're turning a house or your place of work into kind of like a gigantic microcontroller. You have these as your inputs and outputs, and all the logic's just somewhere else. You don't really need to care. So,
what sort of sensors do you have?
So we've got, here's some of our prototype boards. We've got, this guy has an alcohol ethanol sensor. It's got a LPG for natural gas, and it's got carbon monoxide sensor. So one thing we can actually do with this is if you exceed, I think it's 35 parts per million for carbon monoxide, starts getting dangerous. So if you exceed that, and there's various thresholds with different problems at each one. So if you exceed each one of these thresholds, it will automatically send you a text message and an email saying, warning, we detected this much carbon monoxide, and here are the potential symptoms associated with that. So that's something you can do with one of those guys. You put it over by your furnace. So that's a safety node. This one is for our HVAC system, so heating and cooling. It's got a occupancy sensor here, a VIR occupancy sensor. It's got a high accuracy temperature sensor and servo control. So with that, you could make a little vent device. So you've got a servo controlled vent device with temperature and all of that, and you can pick up trending because of the occupancy and know when people are in what rooms. So if you have a guest bedroom, don't bother heating that. If you're away at work, don't bother wasting energy into the house. And the other cool thing about that is because it's so cheap, you can drop a vent unit in every single room in your house and turn your one, maybe two zone system into as many zones as you have rooms in your home. So for real cheap. This guy has a triac device in it. So what you can do is remotely turn on and off these outlets, as well as we have the potential to be able to dim them as well, remotely.
Here's a triac dim, perhaps.
Right.
In a future release.
Yeah.
The theming circuitry is in there, just some of the resistors aren't properly tuned to it.
Right. Yes. The zero crossing stuff.
And everything on the server, like actually the logic behind it is JavaScript, which is it's actually very high performance near C sort of level capabilities. However, a lot of people can learn it really quickly, and we find that it really behaves well with the event-driven nature of devices. So.